In chemistry, when we talk about a system, we also talk about the enthalpy of a system. So what is it? Well, enthalpy is given the symbol H, and it is an energy component of a system. And as such, it has a unit of joules. One of the definitions for enthalpy is that it is the sum of internal energy of a system and the product of pressure volume. So what does that mean? Well, we'll have to turn to mathematics. So enthalpy H equals internal energy U plus pressure volume. So P times V. We cannot measure U directly, however, we can measure the change in internal energy, so delta U. And if I make this delta U, then I have to make this delta H. So now we are saying that change in enthalpy is equal to the change in internal energy plus the change in pressure volume. And I'm going to rewrite this a little bit. I'm going to say delta H equals delta U plus pressure delta V. What I'm saying here is that the change in enthalpy equals the change in internal energy plus change in volume at constant pressure. And hopefully the reason for doing this will become clear in a moment. Recall that the change in internal energy equals to work done plus heat transfer, or it equals W plus Q. I'm going to substitute this W plus Q for this delta U. And I will rewrite the equation down here. So I'm saying now enthalpy equals the change in internal energy, which I will now write as W plus Q, so work plus heat transfer. And now I have to deal with this pressure delta V. Well, it turns out that one of the definitions for work is negative pressure delta V. And I can rewrite this a little bit, and I can say that negative work, let's make that red, so negative work equals positive pressure delta V. So now this term is the same as this term here. And I can substitute this negative W for P delta V down here. So now we have minus W. If I solve for enthalpy or change in enthalpy, I will get that delta H equals Q, because this work and this work will cancel. Now you may wonder, why is this important? Well, it is important because I can determine Q, so I can determine the heat transfer of a system by measuring the change in temperature of a system. So delta T will give me Q, which will give me the enthalpy of a system. And the enthalpy of the system is an energy component of the system. I should also mention that this holds true at constant pressure. And in chemistry, when we are dealing with reactions, we are mostly dealing with systems at constant pressure, which means we can use this equation quite often and quite readily.